Okay, next coming to the stage we have Don Shin. Don Shin is CEO of Crosscom, an award-winning consultancy that's been deploying emerging technologies for over 25 years. He's presenting his talk, Empowering Your Product with Agentic AI, how Model Context Protocol unlocks autonomous AI systems that drive real business outcomes without rebuilding your tech stack. Please welcome Don on to... In a minute, we will give an uproarious applause for Don. He's just getting his mic finalized, and now he is approaching the stage. Does anyone remember Price is Right? Let's cheer him on.
Thank you. While we're getting set up with my deck, quick survey. Who here has a developer background? Raise your hand. Just so I know my audience. Who here has a product background? Here for product, okay. And just business outside of product, just wanted to learn. Okay, great. Well, thank you for the warm introduction, and thank you for the conference organizers. Haven't they done a great job in putting this all together here in Asheville? My talk is going to be on empowering your product with Agentic AI, what to know about Model Context Protocol. The previous speaker to me said he hated the term context engineering, and I'm here to say context is king. I won't use the term context engineering just yet, but we're going to get into why Model Context Protocol can enable your existing product or a new product that you have planned down the pipeline with agentic capabilities. Before we go too far deep into that, it's all good to level set and make sure that we're using the same terminology. I use agentic AI to describe behavior that where you can utilize AI to accomplish work. That is in contrast to assistant AI, basically the way we used to use ChatGPT as a substitute for Google and learning new things and getting information, but I'm wanting to basically explain how Model Context Protocol can help you all implement agentic behavior into your product. I've been doing consulting as part of my own company, Crosscom, for a little more than 25 years. And so I've been doing all sorts of things from web application development, mobile application development, AR, VR. But my story is a little bit relevant because I've seen a lot of things and got my start cutting my teeth on developing websites on Netscape 1.1. History doesn't repeat itself, but it often rhymes. And back then, when we were building websites, we were building these monolithic things that served a lot of information, but didn't really integrate with the outside world or integrate with other systems. Then Web 2.0 came out, and websites started to utilize RESTful APIs, services, and started to become a lot more useful. Websites became web apps. And I'm seeing that kind of transition happen today, where at first we developed early prototypes of large language model powered applications, but they didn't really integrate with many other systems. And the kind of integrations they did have were custom built and very brittle and not very modular or expansive. And there were no integration standards to these early prototypes that happened literally just like a year ago or 2 years ago. Enter Model Context Protocol, which is a standardized way for large language model powered applications to be able to interface with other systems to be able to grab additional context. Context engineering, context is king. And therefore become a lot more useful to the end user when that large language model powered application has the right context. It allows large language models to discover new services, to discover new tools, and discover information, and to be able to pick and choose what information it needs in order to accomplish its goal, and therefore perform work, thereby executing agentic behavior. So, instead of me just talking about Model Context Protocol, it's always just easier to show it in action, and for most people it clicks. Because I'm not using my own laptop, I ended up recording some screen sharing videos of me using Model Context Protocol. Actually recorded those videos on the drive over to Asheville. I wasn't driving at the time, my wife was. But did that yesterday, and hopefully we'll be able to get the gist. So this is me using a chat interface. This one in particular happens to be Anthropic's Claude desktop, but it could be ChatGPT at this point, because ChatGPT also supports Model Context Protocol. Now imagine a world where Model Context Protocol and integrations didn't exist. If I were to type in, summarize the latest 10 messages in the AI productivity Slack channel, what do you think would happen? Hallucinate? That's a great, yep. Or it might just, if you're lucky, it might admit defeat and say, I just can't do what you're asking me to do. I don't have access to Slack or any tools to connect to your Slack channel, so I can't retrieve or summarize messages from the AI productivity channel. Thank you for letting me know. Now, what I'm going to do is also show you a screen share where I have now activated Model Context Protocol, and I have connected it with two MCP, Model Context Protocol servers, one for Slack and one for my company's project management system, ClickUp. And let's see, let's give it something a little bit more complex. I am a busy CEO that is interested in truly strategic knowledge about AI. Look at the 10 most recent messages on the AI Productivity Slack channel, including threads and replies for any messages of strategic importance. Then create corresponding tasks in the MCP Sandbox ClickUp workspace for reading later. Add a summary of the relevant content in the task description, along with a Slack URL to the original message, and prioritize the task according to strategic importance. Ignore messages that offer no strategic value. And as you could see, something different is happening. The LLM, in this case Claude, is actually taking my request, looking at the tools under its disposal, and starting to invoke those tools to get a list of my Slack channels, match and find the AI productivity channel, get the channel history, and retrieve threads and replies. And we actually, in my company, have this AI productivity Slack channel as a way for my entire team to share tools and tips on how to better use AI as software developers and as people in business. And it's actually been a really great forum for us. Interestingly enough, one of the posts recently was on the article that someone else had mentioned about how agentic coding could actually be counterproductive and be 20% slower. Well, a couple of thoughts on that. Firstly, it was a sample size of actually 16 developers, so it was actually a small sample size. Secondly, if you're going to do agentic coding, there are a few principles in mind. I know that this is not the topic of the presentation, but agentic coding works a lot better, firstly, when you make context king and invest in your context file. What that means is that if you're using Cursor, there is a context file where you can put instructions and prepend context to all of your inquiries to the LLM. When you're doing Claude code, there's a Claude MD file where you could actually invest intelligence and instructions into all your LLM interactions. And whenever you get something that is less than satisfactory out of your agentic coding, start over again and improve your context file so that it does the same request but better. And keep investing in your context file rather than trying to iterate through a very, very long thread and get into a doom loop. That is a few things that have worked for us in trying to better execute agentic coding. So look what happened here. Basically, I asked Claude to summarize all the strategic information in my AI productivity channel, and then it created a bunch of ClickUp tasks for me with summaries as basically to-dos for me to catch up on all the strategic information. And that's agentic behavior right there through Model Context Protocol. And these are my ClickUp tasks. So what just happened there under the hood? My MCP host app, in this case Claude Desktop, contained an MCP client implementation that interfaced with two MCP servers, a Slack MCP server and a ClickUp MCP server. And those MCP servers, upon initialization of my Claude Desktop app, told Claude Desktop what kind of tools were available for LLM use. And then when I asked that long prompt, I'm a very busy CEO and I want you to summarize what's going on in this AI productivity Slack channel, it took that prompt and looked at my tools and decided which tools it wanted to invoke. And it decided to invoke tools like get my list of Slack channels, get my Slack channel history, get the threads and replies, so that it could fulfill my original request. Then the LLM decided to not just invoke those tools, but also then take the responses from those tools, the Slack messages, and then construct a response for human consumption. And that's how I was able to not only retrieve Slack history, but also create the ClickUp tools. Any questions so far, by the way?
Is that the video we saw where it was creating the ClickUp tasks?
Yes.
Was that Claude doing that? I mean, the
That
mouse
was-
was moving around, so it.
That was Claude doing it all, yeah. That was basically the LLM, not just providing AI assistance, but AI agentic work through invoking the ClickUp MCP tools to create those corresponding ClickUp tasks for me.
Sorry to interject.
Hey,
I think he was asking at the end, there's a portion where you.
Sorry to interject. I think at the end there's a portion he was asking where you navigate to ClickUp to view what Claude did. But I think he was literally asking, like, was Claude controlling the cursor in that moment when you were viewing that web page? Which I think is not the case.
That is not the case. I switched over to my web browser to show the tasks that had resulted from the agentic behavior through MCP integration. How I got Claude Desktop set up with those MCP servers is basically configuring a settings file and pointing Claude Desktop to those two MCP servers. Oftentimes, you can install an MCP server locally to run on your local machine, or you could actually point it to an MCP server running remotely over HTTPS, and that's becoming increasingly commonplace. MCP servers provide three things for MCP clients and host apps: resources, prompts, and tools. I'm going to go really quick over resources and prompts because I want to focus on tools, which is where a lot of the fun happens. Resources are typically read-only information that you want to expose to the LLM to improve the context so that it can fulfill the original user query. Fixed resources can be PDF files, it could be a knowledge base, it could be log files, or it could even be a subdirectory of your local file system that you want to expose to the LLM so that it could better respond to your agentic requests. Those resources are exposed to the LLM as fixed URIs, or they could be URI templates to be able to access, for instance, repos on GitHub. The MCP server protocol allows for a way for MCP clients to subscribe to changes so that, for instance, if you did expose your local file system to an LLM-powered app, it can actually know when the underlying file system has changed, or the resources have been updated, and take that into account in its answers. Resources are application controlled, which means that the host application, in this case Claude Desktop, decides how it wants to handle those resources. Prompts are like macros, but for prompt engineering. They're prompt templates that serve as shortcuts that can be invoked by the user to execute some kind of action. We now know that prompts are not just content. Prompts are business logic. And an MCP server can expose a bunch of prompt shortcuts for better user experience. So let me give you an example. What if I had some kind of prompt shortcut called learn more, and my LLM-powered application had a chat interface where I can type in my inquiry to the AI chatbot? I could have a /learn more to invoke that prompt provided by the MCP server, and then it could basically provide some prompt engineering to the LLM and provide a response as part of my end-user experience. Another example could be, what if I was in an AI-savvy word processor, and I saw a document about some information. I saw the word succotash. You know, what's interesting is when I was growing up, I heard Sylvester the cat say, "Suffering succotash." And I actually heard that for quite a while before I understood what succotash really was, because I never grew up eating succotash. Well, I could basically, if the MCP server provided a prompt called define and explain, maybe the application could allow me to highlight the word succotash, right-click on it, select define and explain amongst the prompt templates, and then I could see a pop-up window with a response from the LLM explaining not just the definition of succotash, but also an explanation of some background information. So now tools. Tools enable large language model powered applications to perform actions. Think function calls or method calls, but for your LLM powered app. Tools are model controlled, which means that the LLM itself decides when to invoke those tools that you expose to the LLM. And they don't have to be complex. They could be simple and locally executed, like this BMI calculation here. I can give it a weight and a height, and then it can return back a BMI value. But what else are LLMs really bad at? I mean, they're bad at a lot of things, but this is kind of a hint. Math. LLMs are prediction engines. That's why they're really, really bad at complex math. Think square roots, cubic root, logarithmic functions, logarithm with arbitrary bases. You know, if you were to ask an LLM chatbot what the log 10 of some kind of fractional number is, you might get a different answer every single time. And so what if your LLM-powered application actually required some more deterministic output? What you could do is you could create a log MCP tool, and you can mix the best of both worlds, the probabilistic and stochastic nature of LLMs for you to decide on what to do, plus a handful of deterministic tools like log functions to be able to handle things that LLMs don't do consistently well or provide consistent answers to. That's another way that MCP servers can actually add value to your LLM-powered application. But LLM tools don't necessarily need to be simple. They could actually be really complex and operate across the network, and in fact, even change states, like the Slack MCP server that you saw me doing earlier. Here on the right-hand side is a list of the tools that the Slack MCP server provides as context to the Claude LLM. And with an awareness of these tools, if it sees that my query could benefit from the invocation of those tools, the LLM itself decides to invoke those tools to get to the end result. So I mentioned that this presentation is about product. What does that mean for me as a product person? It means interoperability in the same way that Web 2.0 offered interoperability for web applications. MCP provides interoperability for LLM-powered applications to then safely and cleanly and in a modular fashion interface with external systems. If you have an app or you're a product manager of an app, you could build MCP client functionality into your app, and that would enable your app to then leverage other systems for your customer, existing data and other APIs, and quickly supercharge your LLM-powered application so that it has capabilities beyond the capabilities you've written for that application. How many times have you potentially talked within your organization or an enterprise about adopting AI, and they say, well, the AI needs to interface with our internal systems in order to be useful? MCP is what allows this application to do so in a clean way. And it's super easy to add additional MCP servers. On the right-hand side here is a screenshot of Docker MCP Toolkit. If you have Docker installed on your local machine, you would actually download their MCP Toolkit, and it gives you a selection of about 50 MCP servers that you can activate by a flip of a virtual switch. I have a Windows 11 logo because 2 months ago, Microsoft just announced that it would integrate MCP server functionality into Windows eventually, so that from any MCP client, you could actually control your Windows desktop experience. And that leads me to the second point. If you are a product owner of a platform or a backend, you can integrate MCP server functionality so that a growing number of MCP client apps will be able to connect with and leverage your platform. And that makes your platform a foundational part of other ecosystems and their tech stacks. Just like at Windows integrating MCP server functionality, one of my favorite apps for decades is Adobe Photoshop. You can now control Adobe Photoshop through an MCP server, and therefore leverage Photoshop's capabilities from a client app like Claude or ChatGPT. And that is one way that you can make your product an integral part and a foundation of other people's agentic workflows. Some tips if you want to embark on that path and integrate MCP functionality into your product. Firstly, one super easy place to start is to wrap an existing API with an MCP server so that LLMs can then interface with your existing investment if you've already built a public-facing API. Also, consider adding MCP client functionality when you are or your customer is trying to solve business problems for which there is a high level of complexity around context, or if the use case could benefit from context from multiple data sources. Case in point, I run a consultancy. I want my product managers and my project managers, when they're dealing with clients, I want them to be able to put in queries to an LLM like Claude and interface with previous Teams chats, transcripts of previous conversations with the client records on Dropbox. All of those things from multiple data sources can serve to supercharge and add value to my project managers when they're trying to answer questions about client history or trying to figure out how to best respond to a client inquiry about a particular topic that may or may not have been addressed in the past. You could use MCP architecture to easily and quickly add agentic tool invocation. It is super easy to add MCP server and client functionality to your existing product. If you go to modelcontextprotocol.io, there's already software development kits in TypeScript, Python, Java, C#.NET, Swift, and Kotlin for integrating both client and server functionality into your digital product. If your product is a SaaS, providing an MCP server is great for allowing, again, your platform to become an indispensable part of other people's agentic workflow. You could let an open source developer create an MCP server for your API, but why surrender the user experience to an open source developer when you as the product owner can control that user experience and create great MCP servers for your API? What is a great MCP server? It's an MCP server that provides useful tools. It's an MCP server that provides self-documenting tool names because an LLM has to figure out whether or not to use the tool. And it's an MCP server that provides useful error messages so a large language model knows whether or not to understand that error message and then potentially try to invoke that tool again with that error message into account. Finally, with the advent of Web 2.0, we saw the advent of service-oriented architecture, and that allowed us to build systems that were a lot more clean, a lot more modular, and a lot more maintainable. MCP allows you to build large language model systems that are modular, reusable, and easy to expand upon in a way where if you encapsulate functionality into an MCP server or client, you can then build a suite of products that utilize that same investment over and over again. Bottom line, there really is no excuse to be able to integrate Model Context Protocol. It's a way to add a lot of value to your end users by adding agentic behavior to your client apps, and again, make your backends and platforms an indispensable part of existing agentic workflows so that your technology can become more popularized. That's it. Open to questions.
Thank you, Don.
Go ahead. Oh, sorry.
Thank you. My question is about, and I'm interested from hearing from anyone who can answer this, is how do you decide what to charge for this? How do you evaluate it against your current offerings and how it might cannibalize those? And how are people wrestling with those questions?
Yeah, I think that the answer is a lot easier when you're already tolling for the use of your API. Like for instance, we have to pay for consumption of Google Maps API or something, or we have to pay for OpenAI's API based upon token. So if you already have a backend platform for which you are tolling usage through your API, it's a no-brainer to then expose it via Model Context Protocol so that it then gets utilized more. I think that's where you have to really figure out how you go about monetizing and getting value out of your technology being popularized and becoming a part of other people's workflow. That could be through a license, that could be through an API key, or a variety of means in the same way that you would think about an API.
Is there like a common ratio of, per use versus what you're charging per? Is there a common ratio or for what you might charge per subscriber, per year, versus what you're charging per, individual query access, or any sort of guidelines of that sort?
I think it all depends on the cost of consumption for the API, underlying API itself. I will say that there's a huge amount of ROI in implementing MCP client functionality into your app, because I'm seeing chat functionality integrated into ClickUp, into Jira, into pretty much any online app. And if there was MCP client functionality that allowed me to leverage my other systems from that interface, they've now captured my eyeballs. And I'm using their interface to then interface with all my underlying systems and data sources.
Yes, I have a question about security regarding MCP. So the data that you're exposing to an MCP, how do you keep it from, I guess, from a security standpoint, you don't want sensitive data to be exposed. It kind of goes without saying, I would imagine. But what keeps the AI from really going outside of? Is the guardrails really there to really keep it from creeping in its scope?
Yeah. So when you have MCP servers that access potentially sensitive or private data, then you have to also make sure that the underlying API is modeled with access control in mind. And that might mean that output is limited or different if there is no particular API key that's submitted. And by the way, whenever it comes to secrets or API keys or any kind of credentials, that should not actually be submitted on the LLM level. It should actually be part of the MCP server level, which means that maybe there's a separate authentication process, or maybe there's a settings file for the MCP server to input your secret or your API key so that the LLM never sees it.
I see a lot of hands up, but we got to keep moving. So thank you, Don.
Yes.
Appreciate it.
Thank you. Anyone have any questions? Happy to talk some more, or feel free to link in with me later.